All right, all right, all right. Let's get on continuing. We're going to do some first derivative test examples. I want you guys to try it right now. You're going to try f of x equals negative x cubed plus 3/2 x squared plus 18x. Try doing it with the steps we did in the last video. Pause this video real quick to do it. All right, I'll assume you did. When I took the derivative, I had negative 3 times x squared plus 3x plus 18. And I factored out the negative 3, but I'm not going to get rid of the negative 3. The negative 3 is actually really important. So when we're doing our sign chart down below, well, I got rid of negative 3 to like calculate the values here. But notice when I was doing my calculations, I had the negative 3 plugged in. So, because it does affect the sign of the derivative. So you can't get rid of it when you're testing values. But to find critical values, it's fine to divide by the negative 3. So I found the critical values at negative 2 and 3 by setting these each equal to 0. And I'm going to make a little sign chart. So if I plug in negative 10, that's to the left of negative 2. I have a negative times a negative. Negative, this ends up being negative if we look at it. And negative 10 plus 2, that's negative. 3 negatives make a negative, which means this region is doing something like this. It's decreasing. And then if I stick in a 0, this is still negative. 0 minus 3 is a negative, and 0 plus 2 is a positive. I end up with two negative numbers. Two negatives make a positive. Positive means the derivative is increasing here. And for 10, if you stick in 10, you're going to get only one negative, the negative 3, which means decreasing here. And we'll have a graph of this later on because we're going to do more with this in the next videos. But notice if you had gotten rid of the negative 3, if this was gone, you wouldn't have that sign there, and this would have been a plus. You would have gotten rid of that there, not had that there. This would have been a minus, and you wouldn't have had that, so this would have been a plus. So you would have had it looking like this, which is not what happened. Nope, other way around. Yeah, you would have had that, which is opposite of what we have. So that negative 3 has got to be in there. It looks like we've got a bool here, so this is a min. And we've got a peak here, so a max. And so we can identify our values like that. We've got a local max at x equals 2. Or negative 2. I'm sorry, local max is at x equals 3. And a local min at x equals negative 2. Let's pick a different color for this. And so our critical point and these points will be 3 f of 3 and negative 2 f of negative 2. And I have values for these later on. I don't remember what they're at when I graph this later on after we do the second derivative test, as you'll see. I got another example for you. It's complicated. Take your time with it. Try f of x equals 5x to the 1/3 minus x to the 5/3. Pause the video, take the derivative. You might want to get a common denominator when you get the derivative so you can check where the top equals 0, bottom equals 0. All right, I'll figure you did that. I get 5/3 x to the negative 2/3 minus 5/3 x to the 2/3. I rewrote it where we got rid of the negative exponent so I could see it a little bit better. And what I did here is I multiplied this multiplied by x to the 2/3 over x to the 2/3. That gave me x to the 4/3 there, and so I was able to have a common denominator. Okay. So when the top equals 0, we've got a critical point or critical value. When the bottom equals 0, we have a critical value. So I set the top equal to 0, and I solve, and I find that x equals plus or minus 1. And I set the bottom equal to 0, and that's just 0. That's where it's undefined. And it's worth writing, like, if you look at it in this format right here, where I use radical signs, and I put the cube root on the inside, I think you will find that it's easier to recognize the bottom is something squared. Something squared is always positive as long as x doesn't equal 0. The top has 1 minus something positive, so we just got to figure out what that is. But looking at it that way kind of helps us with some later steps and simplifies the next step where I'm doing my sign chart. I use things that I could take a cube root of easily. You'll notice I have my critical values of -1, 0, and 1 here. But the values I use, because I have a cube root here, I use something that I know the cube root for. Cube root of 8 is 2. So that kind of makes this all a little bit easier if I keep that in mind. So on this one, the only part I need to look at, the bottom's always positive. I just need to know the sign of the top. So that's what I'm doing here. I'm looking for the sign of the top. So 1 minus, we take the cube root of -8 and we square it. Cube root of -8 is -2, not square it, raise it to the 4th power. -2 to the 4th power is 16. 1 minus 16 is negative, which means we're doing some downhill shit right here. We're decreasing in this region. In fact, I'm going to hold off doing this sign because you'll see in a second. When we do -1/8, the cube root of -1/8, this you can do is cube root of -1 over the cube root of 8. Don't do both negative because that'll cancel. But this gets you -1 over 2. That's what I was doing right there. Okay? Or you can throw it in the calculator, but trying to do stuff without a calculator is better. I've got -1/2 to the 4th power. Anything to the 4th power is positive. So, and 1/2 to the 4th power is 1/16. So 1 minus 1/16, that's a positive region. So we're going to be going upward there. We're going down here. If I do 1/8 again, I still get a positive 1/16. So when I subtract that from 1, I'm positive again here. And when I do 8, the cube root of 8 is 2. 2 to the 4th is 16. We're back to being negative. So this is decreasing. This is increasing, and then it's increasing again after 0, and then it's decreasing. So it looks like if we're looking at our curve, like how it's curving, it looks like it's doing this. So we've got a min at -1, and we've got a max at +1, but a big fat nothing going on here at 0. Okay? So it looks like we have a local max at x equals 1. So 1, comma f of 1. And what was our function? 5 minus 5x to the 1/3. It looks like a 4. Should be 1, comma 4. We have a local min at x equals -1. This would be -1, comma -4. If I plug it in, I'll write f of -1 here. And what about at x equals 0? Well, remember, if we look at f of x is right here. I can plug in 0, right? 0 to the 1/3 power is the cube root of 0. So, like, f of 0 exists. f of 0 exists, which means it's just the derivative that's kind of wonky. And when the derivative is off, it doesn't exist there. We either have a cusp or a vertical tangent. And when we take a look at the graph, we see that it is a vertical tangent line right there. So that's what we're getting. We're actually getting the vertical tangent at x equals 0. Okay? All right. I'm going to stop this video. Next, we're doing concavity and inflection points.